Hi guys, I just want to examine two questions here quickly um, from chapter 3 now that we're finished. There are two that are taken or adapted from exam papers, and they're both ones that give students trouble that I've seen a lot. So I just want to go through them for a bit. It's on page 134, questions 10b and question 11b. So question 10b, these are all to do with the geometric interpretation of complex numbers. We've got four complex numbers, z1, z2, z3, z4. We don't know which one's which. They satisfy these three conditions here, okay? And they say the same scale was used on both axes. In this question, they've actually given you 1, 2, 3, 4, 5. In the exam, they just gave you blank axes that they said were the same scale. Identify which number is which by labeling each point in the diagram. Write down an approximate value of k. Okay, well, working through it, what you might see first of all is that these two numbers are in the same line. Now, if they are in the same line, what that means is that one is a multiple of another, where that multiple is a real number. The one is one, the other multiplied by a real number. So that's condition 2, okay, where k is z3 is k times z1, where k is a real number. So one of these is z1 and one is z3. Now you don't know if k is greater than 1, that means you've taken a small number and extended it. If k is less than 1, it means you've taken a large number and contracted it. So you don't know yet which one is which. If you go back to this first condition, z2 is I, z1. That's a 90-degree anti-clockwise rotation. So where do we see that 90-degree anti-clockwise rotation? Well, I think here, put that in at the axis, you can see that these two, you've got a 90-degree anti-clockwise rotation. So that means that this one is z1 multiplied by I gives z2, okay, and then multiplied by k it gives z3. So z3 is here, so k has to be smaller. So when they ask for an approximate value of k, probably a half. To get from 6 to 3 on the imaginary axis from 4 to 2, you'd be multiplying by a half. That means this one up here is z4. Okay, you've added two numbers together, z2 plus z3. You're going to see a translation. So z2 was this one plus z3 this one. Well, that's across 3 up 2. So from here you get the translation across 3 up 2. So what we're seeing here is just the geometric interpretation. State which conditions help to identify the first numbers. Explain the numbers first. Explain your answer. So that condition up there helped us to identify because multiplying by I causes a 90-degree anti-clockwise rotation. Question 11b, a complex number z has a modulus greater than 1. Three numbers z, z squared, and z cubed are shown in the argand diagram. One of them lies on the imaginary axis as shown. Label the points to show which number corresponds to each number. If the modulus is greater than 1, when you square it, you're multiplying by a modulus which is greater than 1, so it gets longer. And when you cube it, it gets longer again. So the shortest distance to the origin is, I would say, probably this one here. So that's z1. When you square it, you get z2, and when you cube it, you get z3. Okay? Now, I think it was a clearer diagram, to be honest, in the exam papers that this is taken from. But anyway, label the points to show which one corresponds. Find theta, the argument of z. Okay, so this is tricky here. If I know the imaginary part, the bit that lies on the imaginary plane, is z cubed, okay, this number here is z cubed, well then, if I was to find z, the argument of z cubed is going to be 90 plus whatever 360-degree rotation. I'm going to say it's plus 360 is 450. The argument of z cubed is 450. I'll tell you why I have to do that now in a second. The argument then, according to De Moivre, so z cubed is something x cos 450 plus, actually let's say 90 plus 360n. Let's do general polar form plus I sine of 90 plus 360n. That will mean that z is going to be x to the power of a third cos of 90 plus 360n plus I sine 90 plus 360n, all to the power of 1/3. And De Moivre's theorem then says that that's x cubed cos of 30 plus 120n plus I sine 30 plus 120n. Okay, so the argument for z, the cubed root of that number, would have to be either when n is 0, the argument will be 30. When n is 1, the argument will be 30 plus 120 equals 150. When n is 2, the argument is 30 plus 240, twice 120, and that's going to be 270. When n is 3, the argument has to be 30 plus 360, which just gets us back to where we started. 390 is the same argument as 30 degrees. So it's one of these, 30, 50, or 270. And if we go back and look at the diagram, I think we'd have to say we made a mistake. 150 is the only one that's going to correspond to anything here. 150 here. So if that's z, that's z squared, and that's z cubed. So my labeling at the start was wrong. That's the method for finding which of the that's the method for finding the argument of z. Okay, I'll see you in class. Thank you.